Hi everyone, welcome to my YouTube channel. I hope you all are doing well. So today in this video we are going to solve the problem container with most water, right? So this is the problem of the day on the Geeks4Geeks platform, and you can find the similar problem on the Leetcode also, right? So this is the same only. So first what we'll be doing, we'll be understanding the problem statement, then the logic part, and then we'll be proceeding to the coding part. But before proceeding further, guys, make sure to subscribe my channel if you haven't subscribed the channel till now. It will really motivate me to create more such content for you. So let's get started with the problem statement now. The problem says given n non-negative integers a1, a2 up till an, where each represents a point at coordinate I, comma ai, n vertical lines are drawn such that the two endpoints of line I is at iai and I0 find two lines which together with x-axis forms a container such that it contains the most water. Note, in case of single vertical line, it will not be able to hold water. Okay, so what we have to do is, like, we are having, see, here this is the image, right? So it would be easy for you to understand, so I'm referring from here. So basically what do we have? We have an array, okay, which is denoting the height, okay, which is denoting the height of certain vertical lines. Now what we are supposed to do is, we are supposed to take two endpoints. We have to suppose to take two lines together such that they can form a container, and in this container we can have most water, right? Basically we have to return the maximum amount of water a container can store. And how will be getting this container? By taking two vertical lines, right? Okay, so here if you will see, right, let's say this is the array we are having along with us. So now here we have 1 8 6 2 5 4 8 3 7. So this is the first line of height 1, next is of 8, next is of 6, next 2, then 5, then 4, then 8, then 3, and then 7. Okay, now, and here you can see the distance between them, how it is going to be. So this is on 0th index, this is on first, second, third, fourth, fifth, sixth, seventh, eighth, right? Overall there should be 9 elements: 1 2 3 4 5 6 7 8 9. Yeah, okay. So if we are talking about this, right, so the max area of water the container can contain is 49, right? So for this given array, the answer is 49. How? So if we are taking these two vertical lines, which one? 8 and 7. We are taking these two vertical lines, right? Now just to think, right, one vertical line is of height 8 and one is of 7. So how much water it can take? It can contain, how much water it can contain, right? So it depends on what? It depends on the line which is of smaller length. So here out of 8 and 7, which one is smaller? Obviously 7, right? And next is the distance that we do need in both in between these two lines. So what is the distance between these two lines? So this is at index 1, this is at index 1, and this is at index 8, right? So 8 minus 1 will be having 7, right? And in terms of height, so we are going to take the height of the vertical line which is smaller, right? That is 7. So 7 cross 7 will be having 49, and that's what our answer is, right? So as we need the maximum area, so the brute force approach that will come into your mind is, right, what we can do is just pick up the first element, pick up the first vertical line, and just try this with other vertical lines. Try a pairing of this vertical line with other vertical lines and just calculate the area, right? Calculate the area, length into which we are going to do, calculate the area. Out of which, for length, what we are going to consider? We are going to consider all the possible combination for each vertical line. Like first you took 1, you will be calculating the area. Then you took 8, you will be calculating the area. Like this, we are the first approach that that will come into your mind, right? So what would be the time complexity for that? The time complexity for that is going to be big O of n square, right? Now can we do something better than this? Can we do something better than this? Can we solve this problem with linear time complexity? Okay, can we do this? Obviously we can. Now one thing to observe here is that our uh, intention is to get the maximum area here, right? That is clear. So let's maintain two pointers. Let's say one is a left pointer pointing to the first element and another is a right pointer pointing to the last element, right? Okay, now see, if you are taking, if I am saying, okay, I'll be taking this pair 1 and 7, I'll be taking this pair, right? So what is the distance between these two? Distance between these two, so this is at 0th index and this is at 8th index, right? Distance is 8, right? And what height I'm going to consider, what, how much water it can have, how much height of water it can take? It depends on the line which is smaller, that is 1, right? We cannot take 7, right? Because how water will be stored, right? We have to take the height of the smaller one, a smaller vertical line. It means 1 we are going to take, right? So what would be the area? If I will ask you what would be the area, so 1 into 8, that is 8 is going to be the area, right? Now if we are taking this pair, so we got 8 as the area. Now just think about it, how we'll be exploring further, how we'll be checking the further possible combinations. Should I decrease the value of right pointer or should I increase the value of left pointer? Now if, let's say, if I'm decreasing the value of right pointer, right, so again this height is not going to be the height, previous height what we took 1, right? And now if I'm in decreasing the value of right pointer, so it is pointing to 3. So 1 and 3, which one is smaller? Obviously 1 is smaller. So again the height I'm going to consider, that would be 1, and on top of this, I reduce the distance even, and with reference to that, what happened, the area is further smaller that we got before. Like now if you will see, right, so 1 and 3, which one is minimum? 1. And what would be the distance? So this is at 0th index and this is at 7th index. So now the area would be 7. Our target is to get the max area, not to reduce it. So that's why if you are coming across a vertical line which is smaller, right, out of the left pointer and the right pointer, they are pointing to the element, whichever is the smaller, right? We have to increase the left pointer if the element which is at the left side, that is smaller, or if the element that is at the right side, that is smaller, we have to increase. Just see, if instead of decreasing the value of right pointer, I will increase the value of left pointer, because see here this one was smaller, right? This one was smaller, right? So there can be a possibility further, if I would explore, I would get some vertical line which is having greater height, and with reference to that I can get some, I can improve my area, the area can be increased. So that's why I will increase the value of left pointer. Right will be here, right will remain here itself at 7 itself. Okay, so now what is the distance between these two? So this is at first index and this is at 8 index. 8 minus 1 will be having 7, and which one is minimum? 7 is minimum. So now you can see the area has been improved. 7 into 7 we got 49, right? Now again we have to make a decision, either to increase the left pointer or decrease the right pointer. Now out of 8 and 7, which one is smaller? 7 is smaller, right? So there can be a possibility I can increase my area further if I will be exploring in the left side, so that's why I'll be decreasing the value of right pointer, right? So a right pointer will be pointing to this 3 now. So that is the approach that we are going to follow, the two-pointer approach, to solve this particular problem. Now you must be clear, right, why this approach is proper, why we can use this approach, right? It should be clear in your mind, right? If you want, just complete it till the end, or take any other test case from here. Just pick any other test case and do a dry run of the approach that I discussed just now. Hope things will be the more clear for you, right? So if this is clear, if the logic is clear, then we'll be discussing the code part now. So here's the code for the approach that we discussed, right? So we are having two pointers here, left as well as right. So left is for the starting index and the right will be pointing to the last index of the array. Right now we have two variables, max area as well as area. So max area will be storing the maximum area that we can get on the combination of two vertical lines. So while left is less than right, so how we are calculating the area for the height, that will be depending on the uh, vertical line which is smaller. That's why we are doing met.min a of right comma a of left. And then for the distance, so for that we'll be doing right minus left, and then we are updating the value of max area, whatever values maximum, either if that is stored in the max area itself or the area that we have calculated, right? So whatever is maximum, we'll be storing that in max area. Now how we'll be updating the value of left and right? So if a of left is less than that of a of right, so then we'll be exploring in the right side, that is we'll be doing left plus plus, otherwise we'll be doing right minus minus, and at the end we are simply returning max area, right? So I hope that is clear. That's it from my side. Thank you so much for watching. The code link is there in the description, so in case you want to refer, you can just check from there, and make sure to join our Telegram community for the discussion if you have any doubts. And for the job updates, we are a family of 8k plus members there. Thank you so much for watching, everyone. Bye bye.